in this section we are going to look at the intermediate value theorem. But before we get started on taking some notes on those things, I just want to look at these problems right here and sort of think through them reasonably first. So the first problem we have says Jeremy's weight for the past 4 months is shown above. So we can see he in January weighed 193, up to April weighed 204. And tells us that Jeremy makes a statement, I have never in my life weighed 200 pounds. Based on the data above, is the statement true or false? Justify your answer. So, we see that Jeremy in January weighed 193. Then, coronavirus hit. By April, he's weighing 204, although he was on his way there in February. So, based on what we know about weight, Jeremy had to weigh 200 pounds at some point because he went from 193 to 204. So, we would say, Jeremy, that doesn't sound accurate. I think that you did weigh 200 pounds. However, if we look over here at this situation, you can see how much the Jones family has paid in federal taxes for the years shown. So we see 2010, they paid $4,511. Each year it appears that their income is increasing, or their taxes are increasing at least, probably due to income increasing. And we see each year it looks like this is increasing, and Mr. Jones is going to make the statement that I have never paid $6,000 in federal taxes. Based on the data above, is the statement true or false? Justify your answer. Now, whenever we're thinking about this situation, we have to understand that taxes are going to be different every year. They can be different primarily based on your income, but then they also might be different because the tax rates have changed. So just because we see an increasing trend here does not necessarily mean that these values are always increasing. Also, we do see we would go from $5,145 to $8,730 here. That does not mean in 2013 that Mr. Jones paid $6,000 in federal taxes. That means really just that they made this amount in these years, because in 2013 he could have had a terrible year and maybe paid $0 in federal taxes, or he could have had a great year and paid $150,000 in federal taxes. We really don't know what happened in these years that are missing. So here we would say this could be a true statement. We don't see that being backed up here necessarily, but this can be a true statement that he never made $6,000. So what's the difference in this situation with Jeremy and his weight claims and the Mr. Jones statement about his federal taxes? Well, there is a major difference in these two situations. Our assumption with weight is that your weight is going to be continuous. So if you're going to weigh 204, then before that you weighed 203, and before that you weighed 202, and so on. You gain weight little by little. So if you go from 193 to 204, somewhere in there you weigh 200 pounds. Now, if you get into technicalities about what if you have something amputated, what if you, have something like that, your weight may change immediately if that happens. Let's not get into that. But in general, weight is going to be continuous. So we know to get from 193 to 204, you got to weigh 200 pounds. However, your amount of money that you pay in federal taxes is not continuous. It's different every single year. It can go up, it can go down. It is not going to be a continuous function. So we couldn't make that same assumption that going from $5,145 to $8,730, we couldn't make that same assumption that at some point in here he had to pay $6,000. So this leads us to the intermediate value theorem. And the intermediate value theorem looks really complicated, but it's really a very simple idea. Okay? The intermediate value theorem says if f is a continuous function, look right there, this is what I was just talking about. F is a continuous function on the closed interval a to b, and d is a number between f of a and f of b, then the intermediate value theorem guarantees that there is at least one number c between a and b such that f of c equals d. So, sounds very complicated, something difficult to understand, but let's draw it out, and I think that really helps. So, if we take this piece by piece, we have, of course, first of all, f must be continuous. So we're looking at a continuous function. And we're looking at that continuous function on the closed interval from a to b. And so a and b, those are values on our x-axis. So I'm just going to put them right here. I'm looking at the first quadrant. You could look in a different quadrant and it'd be fine. D is a number between f of a and f of b. So f of a is going to be here somewhere on the y-axis. And what we've got here at a, f of a, there we've got our endpoint for the graph. And then over here, f of b, I'm going to put it up here. It could be anywhere on that y-axis. F of b means that we've got a point at b, f of b, right here. And so for these points, we have some sort of continuous function. So it might look, I'm going to draw it looking like this, right here. But it doesn't have to look like that. It could be a straight line. It could be some crazy zigzag line. But let's leave it something like this here. So it tells us then D is a number between f of a and f of b. So D, let's use green for that, D is somewhere in here. And we also know that intermediate value theorem guarantees that there is at least one number C between A and B. So it's telling us now that C, she's blue for C, C C has to fall somewhere in here. And there has to be some number such that f of c equals d. So, let's narrow this down a little bit more. Let's say d is right here. I'm going to call this d right here. Well, if I look over at my graph, I've got a point right here, and a point right here, and a point right here that all have about that same y coordinate. So that means, notice it says at least one number. So that means right here could be my C, right here could be my C, right here could be my C. I might call this C1, C2, and C3 because obviously those will all be different numbers. So that is a possibility. If D, let me erase this stuff. If D instead were right here, then we would just have this one single point right here. So my C would be right here. So what we're really thinking about here is wherever that D falls, it's between f of A and f of B. And so what we're really saying is if you're going from this point down here to this point up here, you've got to cross D. That's why this function has to be continuous. If it was piecewise, it wouldn't necessarily have to cross here if it was not a continuous piecewise function. But if this is continuous, you can't get from down here to up here without crossing the dotted line right there at D. So there has to be a point where your y value is D. Alright, so let's look at how this is applied. Okay? Explain why the function f of x equals e to the 2x minus 5 must have at least one 0 on the interval from -1 to 2. And so right here, let's remind ourselves really quickly what a 0 is. That is our x-intercept. And let's also think about the function that we're talking about. E to the 2x minus 5 is an exponential function. exponential functions just look something like this right here. They are continuous everywhere. So the first thing I'm going to say is f of x is continuous. I have to state that. So f of x is continuous. I guess I could say on the interval from -1 to 2, because that's the only interval that we really care about here, although f of x is continuous everywhere. And what I'm going to do is I'm going to find f of -1. I'm going to plug in -1. And so if I plug in -1, I've got e to the 2 times -1 minus 5, which is going to be e to the -2 minus 5. And I'm going to do this. Alright, I've got Desmos up here. So if I go over here and type in our equation, f of x equals e to the 2x minus 5, you can see that I've got this graph here, and Desmos will do this really neat thing where if I do -1, f of -1, it will graph that point for me right there, so I can see that I get, let's say I have a mistake right here, that I get -4.865 is my decimal approximation for that. I don't necessarily need that, but I'm going to write it down just for what I know here. I do know, I may need to know how to do this without a calculator, but I think it helps to see what we're doing here. Alright. And so our other endpoint that we need to know is f of 2. So if we plug 2 into this equation, e to the 2 times 2 minus 5 is going to give us e to the 4th minus 5. And if I go over here to Desmos for that one, 2f of 2, I cannot see this, but I believe it's because it's going to be way up here. There it is. And so that f of 2 is 49.598. 49.598 here. And so if we think about what is happening here, we know this is a continuous function, and at this left-hand endpoint, we have a negative y value. But at the right-hand endpoint here, because we can think of it this way, we're really only looking at this graph from -1 less than x less than 2. Technically, those would be or equal to's, but it's a little harder to. Oh, shoot. I do need the or equal to. How do I do that? Let's see. Less than or equal to. And less than or equal to. Okay. That way our points will show up here. And so we're really only looking at this section right here. And so if we're going from this negative value up to this positive value, then you have to cross 0. You have to cross this y-axis, right, x-axis right here. So the way that we state this, we would say, in this case, therefore, by the intermediate value theorem, since, and I like to write it like this, f of -1, which equals e to the -2 minus 5. Notice I did not use the decimal approximation there, mostly because I don't want to make a rounding error, is less than 0, which is less than e to the 4th minus 5, or another way I could say e to the fourth minus 5 is I could say that's f of 2. This just tells me 0 right here. We're wanting to see here that this 0 falls between f of negative 1 and f of 2. It's not entirely necessary to write this part right here out, where I've got that e to the negative 2 minus 5 and the e to the fourth minus 5, as long as you have those values stated somewhere else, but I kind of like to put them here just to help. So since we have this happening here, we know then that there exists at least one x value on the interval that we're talking about here, negative 1 to 2, such that f of x equals 0. So there has to be one x value. Another way that you could say this is you could say there's at least one c, such that f of c equals 0. That would be fine as well there. So we have proven by the intermediate value theorem. Whenever you do the intermediate value theorem, you must include several parts. So it is essential for intermediate value theorem, first of all, for you to say that f is continuous. If f is not continuous, intermediate value theorem does not apply. Second, it is essential that you say by the intermediate value theorem. I don't mind if you shorten that to IVT in your notes, but I would write that out completely on the exam. Then you must state that whatever value you're talking about is between these two endpoint values. And then you finally must make your conclusion that there has to exist something there. So let's do another problem so we can see what's going on here. Okay, on the interval from negative 1 to 4, prove that the function f shown below, prove that on the function f shown below, there is some c such that f of c equals negative 3. Justify your answer. So if we think about what we're doing here, I'm going to go over here to Desmos really quickly. And so if I graph f of x equals x to the second minus 9 over x minus 5. This graph does have a discontinuity. However, that discontinuity is over here at 5. And we are only looking at this graph from x equals negative 1 to x equals 4 here. So we're only looking in between these two pieces of the graph right here. So that discontinuity does not give us any problems because it does not fall in between these. So the very first thing that we're going to say is that f, first we're going to get a pen instead of a highlighter to write with, that f of x is continuous on the interval from negative 1 to 4. So we know that we have continuity here. What we need to know now is where that f of negative 1 and that f of 4 is at. If I look over here, I can just type in Desmos. You won't be able to use Desmos on the exam, but it just is kind of nice to see the representation of that here. So there is negative 1, f of negative 1, and we'll also have 4, f of 4. And so whenever we do that, we can see these points pop up right here. And so the question is there anywhere where f of c, or you could think of that as your y value, equals -3? If I type in y equals -3, here I can see on this graph right here that this line, let me see if I can make that dotted. I think I can. Yes. Let's make it red so it shows up a little bit differently. And so what we're trying to ask is, does this graph here ever have to pass through this point? And in fact, let me just go ahead and restrict my domain here to -1 less than or equal to x less than or equal to 4. So we're only seeing that part of the graph that we're talking about. So that way we can zoom in a little bit more. So if we're going from up here to down here, do we have to cross that red dotted line? And of course the answer for that is yes. So let's look at how we justify that, because you will probably see intermediate value theorem on the AP exam on the free response questions. It is almost always there. So the way that you're going to say this is, first you're going to find f of -1. And if you find f of -1, if you plug in -1, you're going to have -1 squared minus 9 over -1 minus 5. That's going to give you -8 divided by -6, which is 4/3 here. And so that is your point that you see right here. Let's find f of 4. And if we did f of 4, we've got 4 squared minus 9 over 4 minus 5. And that will give us 16 minus 9 over -1. And so we get 7 over -1, which is -7. So the way that we need to write this, now make sure whenever you're writing this that you put this in the correct order. First of all, let's say, so by the intermediate value theorem, since, and here we have to show that -3 falls between these two values right here. And so the way that I'm going to say that is I'm going to say f of 4. Notice how I'm using 4 first, because f of 4 is -7. That is the lower value. That is less than -3, which is less than 4/3, which is your f of -1. So make sure you put the lower of the two values first, even if you might feel like doing the opposite, because this is our second number in our interval. So since -3 is between -7 and 4/3, the intermediate value theorem guarantees that we have a value such that our y value is -3. So what we would say here, I'm going to say it this way this time. Since this is true, there exists some, I'm going to use a c this time, some c on the interval from -1 to 4, such that f of c equals -3. And in this problem in particular, it's better to use a c because the question used the c here. And so you want to prove that. In fact, you can see I'm pretty much just restating this part of the question. There is some c such that f of c equals -3. I did say there exists, I should put an s on that, exists, some c, which is worded just slightly different, but it's the same thing. So this would justify our conclusion here. Let's try another problem. Okay, here's a multiple choice problem, and so we are going to let f of x equal cosine, x plus cosine of x over 5 minus 3, The intermediate value theorem applied to f on the closed interval -9 to 4 guarantees a solution in the -9 to 4 to which of the following equations. So, in this case, intermediate value theorem applies because this function is continuous everywhere. Cosine's always continuous. If you add in an x or a -3, it doesn't make any difference. So intermediate value theorem applies, plus we can assume that it applies by the way this problem is worded. So what we need to know is we need to know f of -9. And that's going to be -9 plus cosine of -9 over 5 minus 3. Now, this particular problem is not a calculator active problem. So you've got -9 over 3 right here. But what you have to ask yourself is, does this value right here even matter that much? So what we know about cosine is the biggest cosine can ever be is -1, and the smallest cosine can ever be is -1. The largest it can ever be is +1. So here, I know I've got -12, if I combine my -9 and my -3, plus cosine of, this would be -1.8 if you want to think of it in decimal form there. So the lowest this could possibly be would be -13. The highest it could possibly be would be -11. So this is somewhere between -13 and -11. There, because we know cosine is no bigger than 1, or no smaller than -1. If we find f of 4, we're going to have 4 plus cosine of 4 over 5 minus 3. And so we're going to have, that's just going to be 1 plus cosine of 0.8, or you can leave it 4/5. Again, we don't really know this exact value of cosine of 0.8 if we don't have a calculator, but we do know the largest it can be is 1, the smallest it can be is -1. So that means that this value here has to be between 0 and 2. So if we look at this, here we're going from a number that's somewhere between -13 and -11 up to some number between 0 and 2. I do know that it is not 2 because I know cosine of 0.8 is not going to be 1, because I know that to have cosine of 1, I would have to have cosine of 0 or cosine of pi there. Actually, no, that'd be -1, so it'd have to be cosine of 0. So here, 2 is going to be out because it cannot actually equal 2 exactly. 9 is out because 9 is larger than 0 and 2. It does not fall between these two values. So 9 is out, and -20 is way too small, so B would be your best answer here. You can kind of think of it, if you're thinking of a graph, and over here you've got your -9, and over here you've got your 4. Down here, I'm going to put -12 and 1. You've got, you know roughly that your point here, -9, it's got to fall somewhere in here. It might be -13, it might be -11, but it's got to be here somewhere. And then, you know, for 4, that your point's falling somewhere here around 1. It might be as low as 0, it might be as high as 2, although it cannot equal 2. It also will not equal 0. So you're going from here to here. So you can see that -20 would be way down here. 2 would be right at the upper limit right there where it can't reach, and 9 would be up here. So 0, that x-axis would have to be the line that you would have to cross. All right, let's look at the next question. It says, let f be a function such that f of negative 3 is less than 9, less than f of 6. Which of the following statement provides sufficient additional information to conclude that there is a value x equals c in the interval from negative 3 to 6 such that f of c equals 9? So, we know here that f of negative 3 is something below 9. We know f of 6 is something above 9. So let's just think about what this would look on the graph here. I'm going to get rid of what we had for our other problem. So I know I've got the point negative 3 and some number below 9, so maybe 8. And let's move. There it is. And then I know I've got 6, and then I've got some number above 9. Just to be simple, let's pick 10. And so I want to know, is there some point here where f of x or f of c equals 9? So do we have to cross this line here? And so yes, that would be true. However, we need to know the information that has to be given in order for this to be true. So A says f is increasing for all x. B says f is decreasing for all x. C says f of x is constant for all x. And D says there is a value x equals c in the interval from 5 to 7 such that the limit as x approaches c of f of x equals 6. Okay, so let's start and throw out the ones that are most obviously incorrect first. C says that f of x is constant. Constant means that it does not change. It means it's a horizontal line. Well, if that's the case, then we can't have a value, an f of negative 3 value less than the f of 6 value. So this has to be thrown out. Okay? For B, f of x is decreasing for all x. Well, that also is nonsensical, because if f of negative 3 is less than 9, less than f of 6, then our function has to increase at some point. So if it's decreasing, it couldn't possibly have that characteristic if it's decreasing for all x. So B is going to be thrown out. That leaves us between A and D. And so we have, for D, let's look at that first because that's the most complicated. There is a value x equals c in the interval from 5 to 7, such that the limit of f of x limit as x approaches c of f of x equals 6. Now, first of all, we're looking at f of c equals 9, so this really doesn't make sense to say anything about 6. 6 would be down here, and we're talking about between 5 and 7. So between 5 and 7 here, that would be here and here. We have a y value of 6 for our limit. That really doesn't have anything to do with what we're doing here, so D is out. The correct answer for this is A, and that would be because if A is increasing for all x, then A has to be then f of x has to be continuous. And so since it's continuous, it would have to increase from here to here, which means it would have to at some point have a y value of 9 that we see here. Okay. We've got one more we're going to look at. So on the interval from 0 to 4, the function f shown below must have a value x equals c such that, and so we're looking at f of c equals negative 5, f of c equals 2, f of c equals 6, and D, no c value can be determined from the given information. So what this problem is really looking for you to do is it's looking for you to make sure you know the appropriate circumstances when the intermediate value theorem applies. And those circumstances are that we are dealing with a continuous function. So in this case, if we look right here at this denominator, we have a discontinuity at x equals 2. So this function is going to be discontinuous at x equals 2. It is going to be a hole in the graph. So if I go over here, let me graph it really quickly. See, Desmos could get you in trouble if you were allowed to use it, because if you graph it, you don't look like you have a problem. But right here at 2, if I can get exactly there, we have a hole in the graph. So this function is not continuous from 0 to 4. If it's not continuous from 0 to 4, intermediate value theorem does not apply, which means you can't guarantee anything. So D will be the correct answer. So always make sure you check for continuity before you answer